Hey guys, Mr. King here. Today we're going to talk about temperature. We've been talking about in class two types of energy. We've been talking about potential energy, which is stored up energy, and then we've talked about kinetic energy as well. And kinetic energy is the energy an object has when it moves. And that is how we get a difference in temperature. And you can see our heading here is temperature, kinetic energy on the move. The more things move, the higher their temperature. So if you can imagine particles going really slowly, they don't move very much, they don't bang into each other, and as we've talked about, when two objects collide, they not only transfer their energy, but they also create friction, which is a form of heat energy. So if you have objects that are colliding a lot, you have a lot of friction being released, which increases the overall temperature. So we're going to kind of talk about how temperature differs from place to place, and there's a couple different types of ways that temperature is transferred from one area to another. So first off, just our basic definition of temperature. It's a measure of the average kinetic energy of an object's atoms. So what that means is you measure how fast all the atoms are moving. And when we've done labs, when we've talked about the different states of matter, you guys know solids move very slow, they vibrate in place, liquids a little bit faster, gases even faster, and plasma particles, they move very, very quickly. And so when we talk about the temperature of the different states of matter, a solid usually has the lowest temperature because its particles are not moving very quickly. The warmest state of matter then would be plasma because those particles are zooming around, those atoms are colliding into each other, and every time they collide, they release heat. So if you've got millions of atoms moving around quickly and colliding, you're going to have a very high temperature. So when we talk about temperature, we measure it with a thermometer, and you guys have all seen thermometers. We've got a couple different scales. We have our Fahrenheit scale that we use here in the United States. Freezing point is 32 degrees. Boiling point of water is 212 degrees. And so you guys know that in order for it to snow, it's got to get down to 32 degrees. That's kind of the magic number. But boiling point of water is something that's not real commonly discussed, and that's 212 degrees on the Fahrenheit scale. Now we've talked about how the Celsius scale and the metric system is a little easier to understand. When we did our measurement unit, we talked about how whenever you measure in metric units, it's in a scale of 10, which makes it pretty easy. Celsius scale is also pretty easy. Freezing point you can see is 0 and boiling point is 100 degrees. And for me, that's a lot easier to remember than 32 degrees and 212. 0 and 100 make it pretty simple. So the Celsius scale is the one that scientists use when they're doing different experiments. You make the measurements in degrees Celsius because that's what most of the world does. So heat is, when we think about temperature, a lot of people think temperature and heat are kind of interchangeable and it's the same thing, but they're a little bit different. Heat is the transfer of energy from one object to another. So you can imagine if you're holding a glass of hot chocolate and you're holding it in a mug, the warmth from the mug goes from the hot chocolate into your hands and it warms your hands up. Now on the other hand, if you are holding on to a cold glass, let's say you have a glass of ice water in the summertime and your hands are really warm. Some of the warmth from your hand goes into the water. So heat will move from warmer objects to cooler ones. And depending on the time of year and depending on the object you're holding, there's going to be a transfer of heat. If you open up your window in the wintertime, your heat will go outside and it'll feel like it's trying to warm up the outside, but in reality, you would probably feel the cold as well coming in. So it's a transfer of that heat from one area to another. Now the flow of heat would stop when the temperature of two objects is the same. So if we go back to the example of holding a glass of hot chocolate, no longer would the heat flow from the hot chocolate into your hands once they became the exact same temperature. So let's say your hot chocolate is 90 degrees. When you grab it, your hands might be warmer than that. And so you're transferring heat from your hands into the hot chocolate. On the other hand, if your hot chocolate is 110 degrees and your hands are 98 degrees, as our body temperature normally is, the heat energy would come from the hot chocolate into your hands. So it always flows from the warmer object into the cooler object. It tries to make the cooler object warmer so they balance out. Water is kind of a special substance because it takes a large amount of heat to raise its temperature. We're lucky enough to live on Lake Michigan, and if you guys go swimming in the springtime, last May we had days where it was in the 70s and 80s, and you might think, oh, let's go to the beach. Problem is, Lake Michigan was still pretty cold. So if you go swimming in the springtime, the water hasn't had enough time to warm up. If you go swimming in the fall, after the water's had all summer to have the sunshine on it, and we talked about temperature is the movement of the atoms in an object, so we're talking about the sun shining on water and making the atoms move and collide. And the more sun that shines on the water, the warmer it's going to get. And so if we have a month of really sunny days like in August, and we have pretty warm air temperatures, those air atoms are bumping into each other, raising the temperature. The water atoms are bumping into each other, raising the temperature. And Lake Michigan gets to be pretty warm. It can be 75 degrees. That temperature also will hold on. If you go swimming in September, even though the temperature starts to drop, Lake Michigan's still pretty warm. If you guys have ever gone swimming in a pool at night, you know it's cold in the air, but the water temperature stays pretty warm. Maybe you guys have gone swimming and you try to get out, but it's too cold, so you duck back under the water real quick, and then you stand up and you get yourself really cold on your shoulders, and then you dive back down under the water to get them warm again. That's because the water holds its heat better. Okay, so it takes a long time for water to cool down or heat up, and we use water in our cars as a coolant to help keep your engine cool instead of running hot when you're driving down the road. So water's kind of unique in the fact that it doesn't really conduct heat very well. It takes a large amount of heat to raise the temperature of water. So heat, like we talked about, goes from warmer objects to cooler objects, and it can happen in three different ways. The first type of heat transfer is called conduction. Transfer of energy by collisions between atoms. Now you can see there's a glass of coffee or hot chocolate here, and that spoon is getting red. The idea behind this is that water in there is really hot, or the milk or hot chocolate, whatever we have in the cup. It's really warm. And even though that spoon is inside the liquid, the handle is not. You can see the handle sitting out in the open air. But what happens in conduction is the atoms down inside the cup on that piece of silverware, they start to feel the heat from the liquid. And when they get heated up, they start to bang into each other. And when they bang into each other, they collide and they transfer that energy from one atom to another. Now you can imagine if a bunch of the atoms on the spoon start to bump into each other down at the part where you would take a bite from or take a sip from, those continue to bump into each other until they get all the way up the handle, and the actual handle of the spoon could get really hot. If you guys have ever left a metal spoon in a can of soup or in a glass of hot chocolate, and then you go to take a drink of it, or you try to sip off the metal spoon, there's a good chance you've burnt your tongue before. That's because of conduction. It's because the atoms bumped into each other and they transferred their energy from one to another by bumping into each other, and that went all the way throughout the spoon. It's not just one little spot, it spreads throughout the entire thing. It's kind of like a domino effect. When you bump into one atom, the other atoms all have to move. Imagine you're standing in a big group of people in the hallway and someone runs by and bumps into one person. Well, if that person bumps into another, they bump into another, they bump into another, it transfers all that energy, and that's transferring all that heat energy. A second way that heat is transferred is called convection. Convection is what happens in your house. When you guys turn on the heat right now, it's cold outside. When you have the heat on in your house, warm air rises. Its particles are more spread out, and so it rises because it's actually less dense than cold air. So warm air rises. So if you have an upstairs to your house, you'll find that because of convection, it's very warm up in the upper level of your home, and it's also cooler down in the lower level of your home. Probably a lot of you guys spend some time in your basement during the summer months. The reason why that is cold air is actually more dense. If you can imagine the particles or the atoms of cold air, it's kind of boxed in closer together because it's closer to a solid than it is warm air. Because as the particles get really close to each other, that makes it more dense because they're more concentrated in air, so it falls down. And all that cool air falls down in the basement of your home. And so if you want to stay warm in the wintertime, you're probably not in your basement, okay, because the warm air rises up. If you want to stay cool in the summertime, you probably don't go up in the upstairs of your house. Okay, if you don't have any air conditioning or any heat on in your home, you would find there would be a slight difference in temperature just from going to the upstairs and walking down to the basement, because warm air rises and cold air sinks. That's the basic idea of convection. So you can see our definition says transfers heat when particles move between objects or areas that differ in temperature. Yeah, warm air is going to rise up, cold air is going to sink down, and then you're going to have differences in temperature. And this is most common in gases and liquid. For most part, it's gas. Most of the time, it's heat, moving up or moving down. Also, if you've ever been in a pool, you will notice that the top layer of the pool is pretty warm and the bottom is colder. If you've ever swam to the bottom of a 10-foot pool in the deep end, you'll notice it gets a little bit cooler on the bottom. That's because cold water is also more dense than warm water. The particles are closer together, therefore they are more dense, and they sink down to the bottom. The last type of heat transfer is called radiation. Radiation is energy transferred by waves. So this is heat that is in the form of waves, like a microwave, and that's what we use to cook food. You can also have waves of energy from the sun. If you've ever looked out across the horizon like off cement and you guys have ever seen those waves of heat, that's radiation. Okay, that's the warmth of the sun kind of refracting back off the cement, and that heat is transferred in the form of waves. And you can see that sometimes. So there's three types. You got conduction, convection, and radiation. Conduction is where the atoms bump into each other and they transfer their energy and the heat spreads by collisions. Convection is this idea that warm air rises and cold air sinks. You can see in this picture the person has their hands right above the fire, and because the fire has heated up the air particles, they are rising up in the air. They're spreading out more and becoming less dense. Now radiation is the actual heat coming off of the fire. That's the waves of energy coming straight from the fire. It has nothing to do with the air particles, it's the direct waves of heat. So it's a little bit different. You can stand right next to a fire and you can feel the heat coming right off it, even though warm air particles rise up. The warm air particles rising up is convection. The waves of heat that you feel coming off it is radiation. Okay, so those are the three different types of heat transfer. And once again, when we're talking about temperature, this lab that we have done before, talking about the different states of matter. And we can see that these particles don't have a lot of energy. And as soon as I add energy to them, they start to move more. And that kinetic energy gets transferred. And now the particles are banging into each other a lot more. And since they're bouncing around and zooming into each other, they are creating even more heat and raising the temperature. You can see the scale up here. We've got all the way up to 79, now 83 degrees Kelvin. The more they collide, the more energy is transferred. And as these go faster and faster and faster, when two objects collide that are going slow, they don't release a whole lot of heat. But when they're going super fast and they bang into each other, they release tons of heat. And so as you increase the kinetic energy of the particles, you increase the temperature of the object. All right, guys, hope this all makes sense. We'll do some more labs in class to explain this a little bit better. You guys have a wonderful night. Get that WSQ done, write some good questions, and don't forget that quiz on the back. I'll see you guys all tomorrow.